Hi friends, in this video we will learn about another complex data type that is commonly used in Python, and that is the tuple. The tuple is very similar to list in many ways, but they are also different. In this particular demo, we'll explore how tuples are similar to the list. Exactly like list in Python, tuples are ordered collection of elements. The order of fields or elements within a tuple matters. A tuple is initialized using rounded brackets as opposed to square brackets for list. Here we have an empty tuple that have been initialized to the my_tuple variable. You can see that this tuple is empty. Let's see the type of my tuple. You will see that Python recognizes this is as the complex data type tuple. Let's print out this type, and you will find that the result is a little different by consensus. This is of class tuple. This is because these complex types under the hood are actually classes in Python. Only thing that you need to know about classes at this point in time is that they serve as a template for what a particular type looks like. And the function you can invoke on the type string, list, tuples, dictionary, and sets are all classes under the hood. Let's initialize a tuple with 3 numeric values, 1, 2, and 3. Notice that initialization is only different from that of a list in that 3 values are enclosed within rounded brackets as opposed to square bracket. Just like a tuple of numeric types, you can have a tuple of strings. Here we have a string tuple with the strings hello and Python within the tuple. The print function in Python can take in 2 tuples, and it will print out each of these tuples within round brackets. So 1, 2, 3 is within one set of rounded brackets, that is one tuple, and hello Python is within another set of rounded bracket. Just like in the case of strings, you can have a tuple which has data of different types within it. Here the combined tuples we have formed by adding together the elements of the int_tuple and the str_tuple. And you can see that the combined tuple contains the number 1, 2, 3 as well as the strings hello and Python. Python also supports these operations where you can multiply a particular tuple, and the result is a tuple where the elements form the tuples have been repeated thrice. So you multiply the string tuple by 3. Hello Python is present thrice in the result in tuple. Here is a tuple of elements where the elements are of different data types: an integer, a floating point, a mixed tuple. Now in Python, anytime you assign a value to a variable where the value is separated by comma, Python automatically interprets this as a tuple. So even though you left out the rounded brackets, when you assign the my_tuple variable, Python correctly realizes that the my_tuple should be a tuple. When talking about what a list is made up of, we often talk about elements of a list. Fields are what we use to refer to the elements in a tuple. Let's say you wanted to access the individual fields in a tuple and assign these fields values to variable. Here is an assignment statement that is valid in Python. A, B, C equals to my_tuple will assign the first field of your tuple to the variable letter A, the second field to the variable letter B, and the third field to the variable letter C. Just like you can have a list which includes another list as its element, that is nested list. You can have nested tuples as well. Here observe that 4, 5 and 6 are a nested tuple within the outer tuple. The first 3 fields of this nested tuple are the number 1, 2 and 3, and the fourth field is the tuple which contains the field 4, 5 and 6. Tuples can contain not just nested tuples but also nested lists. So you can have a list within a tuple. For example, the list here 8, 4, 6 is within the outer tuple, which we have assigned to the variable mixed tuple. The result here is mixed tuple, which has the string as its first field, a list as its second field, and a nested tuple as its third field. Let's set up a tuple of characters here, which contains the character of term permit. Accessing the fields of a tuple is very similar to how you would access the elements in a list. My_tuple of 0 will access the first field, which contains the character P. Let's see another example. My_tuple of 5 will access the field at index position 5, which is T. Just like with the list, tuple field starts at index position 0. If you try to access a field that is out of range for a particular tuple, such as index value 6, you will find that we'll get an error which says tuple index out of range. Let's access the field at the index position 1 of our mixed tuple. This is the list which contains the element 8, 4 and 6. Now if you want to access a particular element of this list which is contained within the tuple, you can use two square brackets. The first square bracket is used to access the field within the outer tuple, that is our mixed tuple, and the second square bracket is used to access the element within the nested list. The element at index 2 within our mixed tuple is our nested tuple containing the field 1, 2, 3. If you want to access a field of this nested tuple, you can use the two square brackets once again. We access the nested tuple at index position 2 and then access the field within the nested tuple at index position 2. The value is 3. Just like with the list, tuples also support slicing operations. Here, a tuple of characters of the word elephant, and I want to access all of the characters starting from index position 1 onwards. And I get all of the characters starting from 1, which is the field at index position 1 in our tuple. Performing slicing operation on a list gives you a list. Performing slicing operation on a tuple gives you a tuple. And you can specify ranges just like you would in a list. I want all of the characters from 2 up to, but not including 4. That gives me the character E and P. In addition to start and end indices, you can specify step size as well. Here I want to access every second character from the entire list, and what I get here is the result. Tuples also support negative index values. So if you access the field at index position -1, that will give you the last character in our tuple, the last field in our tuple, the character T. We will now initialize another tuple, my_tuple, containing the characters of the word hello. Just like lists or a string, tuple also supports function that you can invoke on them, such as index function, which returns the index position of the input argument that you pass in. Here I want the index position of the character H, that is 0. Python also supports the special keys or keywords, that in the keyword which you can use to check whether a particular element or a field is present in a tuple or a list. E in my_tuple will return true because my_tuple indeed contains the character E. Let's check whether the character T in my_tuple will return false because the only characters are H, E, L, L, O. The character T is not present. Let's check this once again. Let's check whether E is not in my_tuple. Not in is also a keyword, and also observe how these Python keywords are basically just English. E is not in my underscore tuple. That is false because letter small e is indeed present in my underscore tuple in the character of the word hello. Let's say I have an int tuple containing the integer 1, 4, 9 and 9. Just like with a list, I can pass in this tuple to a built-in function such as sum to get the sum of all values of the tuple, which in this case is 23. Let's consider this int underscore tuple 1499. I can convert this to a list as well. Simply pass in the list underscore tuple to our list function, and this will convert our tuple to a list, and you can see that the result is a list because of the square brackets. We can take the same int underscore tuple and convert it to a set. Remember, a set cannot contain duplicate values. We can see the result is a set as specified by curly brackets, and you can see that the duplicate value 9 has been removed from the original tuple. The set contains just 1, 4, 9. No duplicate values are allowed in the set. Now let's try to understand the tuple immutability. If tuples and strings are exactly the same, why do we need both? That seems strange. Well, it's not strange because tuple and strings are actually different. And the significant difference is that the fact that tuple are immutable. Tuples once created cannot be updated. So you will tend to prefer tuples over list if you want an immutable collections. Let's see an example of immutable tuples. Here is a tuple, here of numbers. This tuple cannot be assigned values. So let's say you want to try and use the square brackets to assign a new value to a particular tuple field. This will result in an error. We are trying to update the number at index position 0 for this tuple, and you will see that the Python clearly tells that the tuple object does not support an item assignment. Let's say you have a nested tuple, a tuple of tuples, where one of the field itself is a tuple, such as the tuple containing 6, 5. You can access individual field in tuple using the square brackets, such as we have accessed the field at index value 0. But if you try to update this particular field in a tuple, let's say assigning it a value 9, that is an error. Tuples are immutable, and this is how this significantly differ from list. Say you have a list field within a tuple which have an immutable tuple here, and within that last field in the tuple is a list containing the element 6, 5. Now this tuple itself is immutable, but the list within it is not. Let's see what I mean here. At index 3 within the immutable tuple is our list containing the element 6, 5. Let's say we were to use the double square brackets. Here we first access the list within the tuple and try assign a value to an element of that list. We are accessing the list at index 3, and we are setting the first index of that list to value 100. This is allowed. Observe how the list within the tuple has been updated and now contains the elements 6 and 100. The tuples itself is immutable. The list within the tuple is not. I will now create a new tuple containing the characters of the word Python, so you can see that my underscore tuple is a tuple of characters. This tuple is immutable, and you will find that if you are trying to delete a particular character within this tuple, the one at index position 3, this is also an error. The tuple object does not support item deletion. A tuple once created cannot have its field updated. You cannot delete its field as well, but you can delete the tuple as a whole. You can use the del keyword and free up the memory corresponding to my underscore tuple. Now if you try to access the my underscore tuple variable, Python will throw an error. My underscore tuple is no longer defined since you have deleted it. Now that we have studied the important difference between tuples and lists, let's study some interesting operations we can perform with tuples. Here we have two tuples, tuple underscore A and tuple underscore B. Tuple underscore A is a tuple of numbers and tuple underscore B is a tuple of characters. I'm going to introduce you to the zip function in Python. This is exactly and very, we can say, extremely useful and often used when you are using data science libraries. The zip function is so called because it essentially acts as a zipper would on your clothes. It basically makes pair of every element in tuple underscore A with the corresponding element in tuple underscore B. The result of the built-in zip function is simply an object. You can't really tell what the structure of the object is. In its simplest form, you can think of the zip data structure as a collection of tuples. Every tuple will have one field from tuple underscore A and one field from tuple underscore B. These are the original tuples that you zipped up together. Now what exactly this collection is depends on how you use the zipped result. So if you pass in the zipped result to a tuple function, you will get a tuple of tuples. Here in this example, we have converted the zip result to a tuple. The zipped result can be converted to a tuple. It can be converted to a list, a dictionary, or even a set. Any complex data type that Python supports. Once we converted the zip object to a tuple, we'll store it in the result variable, and here is what the result variable looks like. The result here is a tuple of tuples. Observe the nested tuples within the outer tuple. You can see that every first element of the nested tuple comes from the first tuple that we have zipped up, and the second element comes from the second tuple that we have zipped up. The number 1 from the first tuple is paired with from the second tuple. The 2 from the first tuple is paired with the B from the second tuple, and so on. If you want to extract the original tuple from the zipped result, simply call zip once again, passed in the result with an asterisk at the beginning. For now you can ignore what the asterisk mean and assign the result to tuple underscore X and tuple underscore Y. If you print out the value of tuple underscore X and tuple underscore Y, you'll see these will be the original tuples which you zipped up to get the zipped result. The zip operation is extremely useful to bring two ordered collections together, and the zip operation doesn't work just with tuples, can also work with lists. Here we have two lists, list underscore A and list underscore B, a list of numbers and a list of characters. Let's invoke the built-in zip function on the two lists, pass in the list underscore A and list underscore B to zip. Store the result in zipped underscore list and make a list of the zipped underscore list. And this result is a list of tuples. The result is a list here because we converted the zipped list variable to a list. And notice that every element within the list is a tuple, and each of these tuples contain two fields. The first field from the first list, the second field from the second list, list underscore B. Let's try the zip operation again so that we understand it better. Here we have two tuples A and B. A contains a tuple of names and B contains a tuple of positions within an organization. Invoke the zip function on A and B and store the result in X. Now this zipped result can be converted to a tuple or a list. It can also be converted to a dictionary. Pass in the zipped result X into a dictionary, and then result will be something that makes sense intuitively. The keys of this dictionary are all of the fields from the first tuple, John, Charles, and Mike. and the corresponding values are all of the fields from the second tuple: manager, supervisor, and engine. Another data type in Python is dictionary, which is the mapping of key value pairs. Dictionaries are specified using curly braces. Dictionaries are typically set to contain records. Here is a dictionary with 3 separate records, and every record here is a key value pair. The key for the first record is the string A. The corresponding value is 25. Notice that every key value pair is separated using a colon. Every record is separated from the other records using comma, and all of the records are enclosed within curly braces. So the second key value pair mapping, the key is B, the value is 3.4. The third key value pair mapping, the key is C and the value is 20. So here is what the dictionary looks like. The cool thing about the dictionary, which we will study in more detail later on, is that you can look up values using their key. If you check the type of the my_dictionary variable, you can see that it has data type dict. And the last data type that will be introduced here is set. A set is simply number of elements specified within curly braces. A set in Python is an unordered collection of unique elements. Observe that one of the elements in the set, element 4, has been repeated twice. But when you print out the value of A, you will see that the element 4 occurs exactly once. You can also see that the elements of the set are not printed out in the same order in which we had specified those elements. The set is unordered. You cannot rely on the ordering of elements in the set. And if you check the type of variable, you will see that it is of type set. So this is once again a special data type available in Python. So in this video, we'll keep our learning up to here only. In this video, we try to explore about tuple and its immutability and get a little introduction about dictionary data type and set data type, which are a kind of complex data type in Python. So we'll see you in the next video with more detailing of dictionary and set. Till then, happy learning. Goodbye.